In this video, we're going to see some limits involving natural logarithms. But to evaluate them, we assume that we're already familiar with some basics like these. The limit when x goes to infinity of ln x is positive infinity. The limit when x goes to the 0 from the right of ln x is minus infinity. And limit in 0 from the right of x to the power n ln x is 0. Limit in infinity of ln x over x to the n power is 0. Limit of ln x over x minus 1. This is the derivative in 1, so it's 1. And from this we get this by substituting limit in 0 of ln x plus 1 over x is 1. So we must be really familiar with these limits to applicate it here. Let's start with this one. Limit as x goes to infinity of 2x minus ln x. If we plug infinity, we got plus infinity minus infinity, which is undefined. So we're going to try factorizing here by x. We get the limits. X goes to infinity, x times 2 minus ln x over x. And we have this is 0 when x approaches infinity. So we got infinity times 2. So it's infinity times 2 because this is 0. See here. And infinity times 2 is infinity, positive infinity. The second limit, we got limits when x goes to infinity of ln x over square root of x. We can put x as the square root of x squared. Limit x goes to infinity of ln square root of x squared over square root of x. And as a property of natural log, we can take these two in the front here to get 2 ln of the square root of x. And of course we can take the 2 out of the limit. So it's 2 times the limit x goes to infinity of ln square root of x over square root of x. Now by substituting and putting square root of x as t, we got the limit of ln t over t. When x goes to infinity, the square root of x goes to infinity. So this is 0. So it's 2 times 0, which is 0. The third one, limits x goes to infinity of ln 5x plus 7 over x minus 4. we can see that the limit here is simply to evaluate, because it's a rational function. We take the term with the highest power, so it's the limit of 5x over x, so it's 5. So the limits of ln of 5. So we can write limit on x goes to plus infinity of ln of 5x over x. We can then simplify by x and get ln of 5. Next one, limit when x goes to 0 of ln 1 plus 2x over x. This reminds us of this one, but instead of having x, we have 2x. So if we multiply here by 2 and then by 2 at the top, we can get 1 plus 2x over 2x and put 2x as y and substitute. So it's the limit when x goes to 0 of ln 1 plus 2x over 2x, and we need to multiply by 2 at the top because we multiplied by 2 at the bottom. So this is equal to 1 because when x goes to 0, 2x also goes to 0. So it's 1 times 2. We can take the 2 out and get 2 times 1, which is 2. The last one, x ln 1 plus 1 over x at infinity. We don't have this form in the basic limits, but we can see that we can put x 1 over x as t, so x is 1 over t, so we can put here 1 over x is t, which gives us that x is 1 over t. When x goes to infinity, t goes to 0 if this goes to infinity. So we get 1 over t, the limit, and t goes to 0 of 1 over t ln 1 plus t. Or we can write it this way, limit t goes to 0 of ln 1 plus t over t. And this is a usual limit, it's simply 1.